Hello and welcome to another VMK in the C++ series. In this VMK I'll be describing C++ templates and how to use them in your code. Let's jump right into Visual Studio and start writing some code. I'm going to start off by showing you a few examples of when you'd want to use templates, and then I'll go in and describe what a template is and what the syntax is inside of C++ to be able to implement them. So for instance, let's say that we wanted to write a program that sorts some numbers. So maybe I have two numbers and I would like to know maybe which one's the maximum, which one's the minimum. So to begin, let's say we have two integers. I have integer a, which is going to be 3, and I'll have integer b, which I'll make 5 right now. I want to create a function so that I can say something like this. Int result is going to be the maximum between IA and IB. So I want this max function to return to me which value is largest, either A or B. The way that you would write this function would be something like this. I want to return an integer, my function name is maximum, and I want to be passing in here an integer and another integer. All that we're going to do inside here is take a look to see which of these two values are biggest. So if A is bigger than B, then we want to return A. Otherwise, we're going to be returning B. And after doing this, let's also print to the screen the result. Okay, press Ctrl F5 to run the program, and we see the result is 5. Everything ran fine, compiled okay. We can change the values of these. Let's make A bigger, so let's make it 8. And now when we run the program, you notice that the result is 8. So everything is working as I expect. But now let's say that in your development you end up getting two new numbers, but these new numbers are no longer integers. Let's say that they're floating point numbers. So you'd have FA and FB. And let's say that these numbers are maybe 3.14 and minus 8.7. Well, you'd want to pass these new values into your maximum function, and you'd want to return a value, and then you'd want to display the result. I'm just going to comment this out and change this to be an FR. Okay, if we try to compile this, notice that the compiler complains. It says, warning, initialization, truncation between double and float. Oh, that's my mistake. Here I'm specifying floating point numbers, but I'm actually giving double precision numbers. So we need to add in a F at the back of these numbers to indicate these are floating point numbers. Okay, so the warnings that we're getting is conversion from float to int here, and then a conversion from int to float here. What this means is we're passing in floating point numbers, but notice that our function here only accepts integers. So our code is actually not going to work properly because it's going to take these values and it's going to cast them down to be integers, and then it's going to return a value which is an integer, but then we cast it back into a float. To see that this doesn't work properly, actually let me change this code to be something like this, 3.5. So I want to get the maximum value between 3.14 and 3.5. When I run this code with the existing setup, you notice that the result is 3. 3 isn't a valid answer because FA isn't 3 and FB isn't 3. But because we've casted both of these to be integers and then we return an integer which gets casted to a floating point number, we lose all of the precision of the calculation. So to fix this, we would have to go in here and write a separate function that does basically the same thing, but it accepts floating point numbers. Something like this. Okay, now when we compile the code, notice that there is no warnings because the compiler knows when we call this max function, we're passing in floating point numbers, therefore we must be calling this instance of the function rather than this one here. Now when we run the code, we can see that the return value is 3.5, which is the correct answer. The maximum value between these two is 3.5. And just to confirm that it works the other way, we can make this number larger, maybe make it 7.14, run it through, and now notice it's returning FA rather than FB from our maximum function. Okay, so we've implemented this, and now a little bit later in development you realize that oh no, the numbers that we're getting are not going to be floating point numbers, but are going to be double precision numbers. So you would have to go through this process again, recreate the same function that does exactly the same thing, but using a different data type. So you can see you're going to have 3 functions, or maybe even more, that do exactly the same thing, but have been written for specific data types. This is where templates come in to help simplify your code. So I hope you can see that having multiple functions that do the exact same thing is not very good. Because let's say maybe down the line, if your functions are relatively complex, you find a bug in one of them, you fix it, but you forgot to go and fix it in all the other functions that do the exact same thing based on a different data type. Well, then you're going to run into a lot of problems. So to avoid all of this, we can simplify our code development by using templates. So let's take a look at how these work. Inside of C++, there's a keyword called template. When you type it in, you'll notice it turns blue in Visual Studio. And the way you use it is you type in template and then you put a less than sign to specify that your template is going to be using a specific kind of data type. The data type that you want to use is going to be keyworded by a value that you pass in here. So for instance, I'm going to say that my template is going to have a data type called T. Now below this is where you would write your definition for your function. In our case, we had a return value here of an integer. Now what I want to say is my return value is going to be the same value that we passed into the function, and that value is going to be T. So here we type in T. Then the name of your function, so I'm going to use maximum, and the function itself, you need to pass in a few parameters. Here you can see that I'm passing in 2 values, and they're both integers. So here I can say the first one is going to be A, and the second one is going to be B. Internally, I'm going to do the exact same sort of work that I did before. I'm going to check to see if A is greater than B. If A is greater than B, then we return A, otherwise we're going to return B. So now I've defined my function to be a template function. Down below, we use it exactly the same way that we did before. If I'm passing in a floating point number and then calling the maximum function, the compiler is going to know that I'm passing in floating point parameters into my function. So it's going to create this function when it compiles my code so that this maximum function accepts a floating point number. So let's check this out. I compile it, we get no errors, and when I run the program, it returns 7.14, which is the correct answer. Now let's say that I change my mind and I want integers here. So quickly I'm going to rewrite this to be 5 for A, and for B I'm going to use -4, and then my return value is going to be the maximum between IA and IB. And I'm going to print the result to the screen. We can also comment this code out. Now when I compile this code, notice the compiler doesn't complain, even though I've switched the data types, because it knows maximum is going to get an integer value here. So when it compiles my code, it actually creates this function so that it gets integers passing into here. I can also expand this now so that if I wanted to use both integers and floating point numbers, all I would need to do is uncomment this code, and for instance here I can say result from my integer, and this is going to be the results from my floating point calculation. When I compile this code, the compiler automatically knows, okay, I'm calling maximum here, but I'm passing in floating point numbers. So it's going to create this code with floating point numbers passed in everywhere where you have a T parameter. Down here, it sees that I'm using integers, so it creates another instance of this function, but this time it creates integers where the t is located in this function. And you can see when I run this code, the results are correct. 5 is the maximum value for my integers, and 7.14 is the maximum value for my floating point numbers. So by using a templated function, we can actually simplify the amount of code we need to write, and things become easier to maintain. You can explicitly specify what kind of type definition you'd like to use with your function calls, and the way you do that is if you highlight over this, you can actually kind of see it gives you a hint on how to do it. It says t max type name t, and then it has the parameters that you pass into our maximum function. Well, let's say we had the following case. We had 2 integers, but we want the result to be a floating point number that we return. In this case, if I try to compile this code, you notice that we get a warning message saying that we're converting from an integer to a floating point number because we're passing in these values here as integers, so it's going to create this function as a return type of an integer. However, what we can do here is after the name of our function, we can open up a less than bracket, and inside here we can specify that I want to be using a floating point data type. Now when I compile this, you notice that I get 2 warnings, and it's saying that the argument is getting converted from an integer to a float, and the other argument is also getting converted from integer to a float, but the return value is a float. So what I'm basically doing is I'm forcing this template class to be defined as float, float, and float, and because of that, it's taking these values and converting them to floats from integers. So you can force a function to use a specific data type by passing in the data type that you would like to use inside of the less than and greater than signs after the function name. Now, templates are not restricted to just functions. You can use them also with classes. Let's say we want to create a class. Well, I'll just call it my class, and it's going to have a public section where I'm just going to create one function called swap. This function is not going to return anything, and all it's going to do is it's going to accept 2 values. Let's initially make them integers. And internally what it's going to do is it's going to create a new integer as a temporary value. It's going to make this temporary parameter equal to a, and while we've got that value stored, I'm going to make a equal to b, and then I can make b equal to that temporary value. So I basically swapped the values that are stored in a and b. Now let's try this out. Let's make a equal to 2, let's make b equal to 7, and let's try it out. Because this function is within my class, I need to define a variable that's going to be using that class. I'll just call it c, and c I'm going to pass in my 2 parameters here, ia and ib, and then let's just display the results. Actually, let's display the results before and after the swapping. So before, we're going to have %d and %d. So here I'm going to show IA and IB, and then after I'm going to print IA and IB again. Let's compile this and run it, and you can see that before we have 2 and 7, and then after we have 7 and 2. So those values just got swapped in memory. Now let's say that the same thing happens, and instead of using integers, you're told that you want to swap floating point numbers. Well, if that's the case, we need 2 floating point numbers. FA, let's make this 3.14. Let's make FB equal to 3.3. If I try to use this function as it is right now, we're going to run into a problem because things are going to get casted into integers and the results are not going to be correct. Let's see what happens if we try this. Don't know if this will actually compile. It doesn't compile because it says, okay, it cannot convert a floating point number into an address of an integer. Okay, so we can see we've got a problem. Well, again, we can rectify this problem just by templating our class. Again, we use our template keyword. We specify we're going to use the t parameter here to represent our data type. Now realize this t parameter here doesn't have to be t. It could be anything you like. My data type, for instance. This will work just as well. I just like using t, and you'll notice that t is commonly used whenever you create templates within your C++ code. Oh, I'm actually mixing up a few things here. Before I talk about templating a class, let me just demonstrate templating this function within the class. So just as I did before, I'm going to use the template keyword here above my function name, and then when I define my function, I can say I'm going to use this specific data type that gets passed into here. Internally, I want to create a temporary variable of the same data type, which we'll then use to swap the values that get passed in. Like so. So let's compile this. Notice it compiles okay, and when we run it, we have 3.14, 3.3, and then they get swapped, 3.3 and 3.14. So that's how you'd use a function within a class, but you can take this one step further and actually template the whole class. So for instance, we can take that template keyword out of the class definition so that the template keyword, whatever's passed in here, is actually going to represent that we can use this template anywhere inside of the class. I'm going to change this back to T just because it's less typing for me. You notice that as soon as we do this, we try to compile this code now, compiler is going to complain because it says we're defining a my class data type here, but we didn't actually specify what is this data type going to be. So we need to explicitly now say this class is going to use a specific data type, and the data type that I want to use, well, let's make it a floating point number. So I can compile this. This succeeds. We can run this, and you notice that it swaps the values correctly. So that's how you'd use a template on a class, and this is how you actually instantiate your class that has been templated. You'll notice that templates are used quite heavily when you're starting to use your std functions. There, you'll notice we type in std, let's say vector for instance, and the vector class is templated because you need to specify what data type this vector is going to contain. So in those less than and greater than signs, we always specified the specific data type. So there we're always using templates without actually realizing we are using them. One thing I want to point out here though is if you are defining classes this way that are templated, but you don't want to initialize your code right inside of your class, instead you want to do something like this. Take all of this stuff out. Say that this function swap belongs to my class, and then have the implementation outside of the class. If you're writing code this way, which is the normal way of writing classes, you'd have this inside of your header file and then this part here inside of your source file. Notice that if I try to compile this, it's going to give me a problem. It's going to say, oh, my class here doesn't have a data type. And to fix this, you just need to say, I am using a template within this class. The template is going to have the t parameter here. So over here we need to specify my class of data type t, and here's my function definition. Now when I compile it, it's okay, and I can run it through, and you notice it works correctly. So that was a quick run through on how templates work, both within functions and within classes. And I hope I've demonstrated the power of templates within C++.